Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at the concept of associative arrays within your applications. So what are associative arrays and what can we use them for? An associative array, map, symbol table or dictionary is an abstract data type that stores a collection of pairs of keys and values. Each possible key appears no more than once in the collection. Let's assume we're going to store a list of countries. We could have a 3-letter key for each country and store the full name of the country associated with that key. By entering the key, our application could return the value. Many types of data are structured in this way. For example, bank accounts, where the account number links to the data value or values associated with it. As the key is unique, you should be able to return that information very quickly. So how do we use associative arrays in PowerBasic? We would need a way to add, find, update, and remove entries from the associative array. So do we need to access new libraries or DLLs? No, this functionality is inbuilt to PowerBasic and it's called PowerCollections. Let's have a look at some code to illustrate this. For those of you who have been watching these videos for a while, you will know that we've done several videos on PowerCollections before. So today we're going to revisit them, and we can concentrate in a little more detail on how they actually work. You can now see on screen a list of users with their names, their addresses, their telephone numbers, and an account number. If you look closely at the data, you will see there are in fact 2 John Smiths. So since we need to store a unique identifier for each of these users, we're going to pick the account number. As you would expect, in banking systems, the account number is a unique identifier for the customer. If you have the account number, you should be able to pull any of the information for the customer out of the banking system. This data at the moment is held in a plain CSV file. So our first task in the application is to pull this information into the application and store it in a format which we can put into our PowerCollection. So we will create a user-defined type for this customer's information. We'll call this customers, and it will store the account number as a string of 8 characters. It will store the first name and surname as strings of fixed length 50 characters, the address as 100 characters, and the telephone number as a string of 14 characters. The advantage of using a user-defined type is that you could extend this to include additional information, should the need arise. Since our unique identifier is going to be the account number, we're going to put a prefix on the front of the account number. This way we can use an account number for 2 different purposes. More will become clear when we get to that point in the code. So I'm going to set up a constant for the user prefix, which will be for our user account. So $user prefix in this case is going to be the text user. So as we're going to be using a power collection, we have to define that collection. So we're setting up a global variable called customers as an iPowerCollection. We're then making customers equal to the class PowerCollection. This completes the setting up of the PowerCollection, and we can now look at putting some data into it. So we will now declare a user-defined type as our type. So we're creating UDT customers as uCustomers. uCustomers, as you'll remember, is the user-defined type we set up at the beginning. So as we intend holding 2 different types of information for our customers, we're going to create another local variable to allow us to tell the difference between them. And we'll call that record type. Now we can start to set up some variables which are going to be used to get data into our PowerCollection and to get data out of it. we'll start with the key. The key we are setting up as a local variable as a W string. A W string, or wide string, is a Unicode string. This type of string is slightly different from our ANSI standard strings. The Unicode string stores the data for each character as 2 bytes. This allows the first part to contain information on what character set we're actually talking about. This allows the storage of international character sets and is widely used within the Windows subsystems. Next, we're creating a local variable called long R. We're going to be using this to read through our array. Next, we're declaring a vData variable. This is the variant that's going to be stored in the PowerCollection. And finally, we're storing an item number. This is the record number in the collection itself. So having set these up, how do we get the data that's in our CSV file into the PowerCollection? Well, we're going to create a function whose job it will be to load this raw CSV file into the collection. We're going to call that load raw file. If this new function returns true, then our CSV file has been loaded into the collection. If it returns false, then we will report that we could not load the CSV file. We're taking a single parameter, which is the path and the name of the file we wish to load. As we will see, the myUserData exists in the same folder as our application. So let's create that new function. So here we have the beginning of the new function, taking in its single parameter to load the collection from a CSV file. We're declaring a local array, a long R counter, and also we're declaring our UDT customers as a uCustomers user-defined type. And we're also declaring a local variable for the key. We're then going to call one of the functions in our file handling library. This is read the file into an array. This useful function takes 2 parameters, the name of the file you're reading and the array into which you want to put the data. The use of such library functions saves you quite a lot of coding because quite often you'll be loading files into arrays. So this populates a one-dimensional array. And then for each row in that array, we're going to read through it one row at a time. And next we're using the prefix command to allow us to define each of the elements within our user-defined type. And we're adding to each of these elements a piece of data. In this case, we're taking the user prefix, which is the text user, and we're adding onto that the 5th column from our CSV file, the account number, by using the parse command. And we're doing the same for each of the other elements of our user-defined type, the name, the surname, the address, and the telephone number. So we now have populated our user-defined type. The next task is to place that within the customer's PowerCollection. So we're setting, first of all, the key to be the account number. And then we're using the add method in the PowerCollection to add our data to the collection. It takes 2 parameters, the first being the key, the second being the user-defined type. If the value of object result is SOK, then the operation has been successful and we have stored that information within the PowerCollection. If that returns a value other than SOK, then either there has been an error inserting or that data has already been stored in the collection. With your PowerCollection, the key value must be unique. So this would prevent putting a duplicate key into the system. And if we get that far, we're returning true to the calling function. So if we go back to the PB main function, if we get this far, then the data will have been loaded into the PowerCollection. So if that's the case, can we also pull the data out of the collection and put it out to another file, just to prove we have been successful in storing the data? So we're going to call another new function, save collection. Again, it's going to take a single parameter, This is the path and the name of the file we wish to create with the data that's currently within the collection. So let's create that new function now. So here is our new function, taking its single parameter, which is the path and the name of the file to actually create. We're creating some local variables to allow us to pull the information out of the collection. And we're opening our file to which we're going to be saving. And then we can use the equivalent of a for next loop on the PowerCollection itself, using for each vData in customers. Customers is the name of the PowerCollection, and vData is a variant. And we're converting the data within vData to a string, and we're storing that within the record type variable. And we're looking at the first 4 characters of that to determine whether this is a user-defined type, or it's the account one we have not yet used. We'll cover the account one in more detail later. So as the data within a collection is all user data, this piece of code is the one that's going to execute. And we're using the typeset command. This is populating this user-defined type, customer out. And it's taking the information that's coming out of our variant. This quite easily populates this user-defined type using a single line of code. And we're printing that data out to the file we wish to output to. As we're going to be handling account data separately later on, we're going to declare another user-defined type before we try running this. So as well as the customer's user-defined type, we're going to set up another user-defined type to hold account information. In this case, an account number with balance and transactions. And we'll define a new prefix for this account data using a CCT, which will appear before the key in the PowerCollection. So let's try running our application now and see how far we get. Well, we're getting the information coming up to say we have a number of entries stored in our PowerCollection. And additionally, we're getting a message to say we have successfully saved the collection to disk. So let's have a look at what's come out. In our folder, we now have a customers.txt file. If we open that up, we will see that it stores information from the PowerCollection in a flat text file. The account number with its prefix, the person's name as a 50-character wide string, the person's surname similarly stored, and all the other data. So you can quite easily see we've pulled the information in from the CSV file and we've output it to the text file. So now that we've actually saved information into this customers.txt file, that's the content of our PowerCollection. So I'm going to comment out these 2 functions we have created which pull it in from the raw CSV file, as we won't need these at the moment. Since we have the information in the customers.txt file, we can then load it directly from there. So we're going to use yet another new function called loadCollection. This will populate the PowerCollection directly from the customers.txt file. So let's create that new function. So here we are in the new function, taking its single parameter, specifying the file we're going to be loading the collection from disk. As we did before, we're setting up a number of local variables. A file handle, a customer string, the user-defined type we're going to be storing information into, and one for the accounts, which we haven't created yet, but we will be doing shortly. As we did before, we're using a W key as a W string variable, which is our unique identifier in the PowerCollection. And as we did before, we're opening up a file. We're running a while loop to handle every record within that file. And we're using the typeset command to populate the user-defined type for each of the records. As we did before, we can quite easily define our key, which is coming out from the user-defined type, and we're using the customers add method again to add our data to the PowerCollection. And when we create the account data, we'll be doing exactly the same for it. And if the object result is SOK, then we have successfully stored the information in the collection. Otherwise, it's going to give us a message to say it's already been stored or there has been an error. And the function will return true if all has gone well. So having loaded the collection, can we tell how many records are actually sitting within the customer's PowerCollection? We can using customers.count. So we will print out to our log the number of records we find within the customer's PowerCollection. If we run that code now, we will see we have successfully stored 9 records from the data, and we're reporting 9 records found in the collection. So we've loaded up the text file, put it into the collection, and reported on the number of records. So now that we have a PowerCollection running, how do we add a new record to the collection, one that did not exist in the original CSV file? Well, first of all, we need to populate the user-defined type. So we can use our prefix command again to make it easy to add to each of the elements in the user-defined type. So we're adding on a new account number of 1300. As you will see from the data, there is not currently an entry for 1300, so we should have no problem storing this information. We're putting the name in as Fred Smith, we're putting the address in, and we're putting their telephone number in as well. So as we did before, we're populating the key with the account number. And we're using customers.add to add this piece of information to our PowerCollection. The use of user-defined types is quite useful as it gives you a little packet of data you can add quite easily to PowerCollections. So now that we've added this extra piece of information, can we display how many records we've got in, which should now show 10 rather than 9, as we've added one additional record. So we'll push out the customer's count back to the log. If we run that code now, we will see it's gone from 9 records found up to 10. So we've successfully stored an additional record. So our PowerCollection at the moment holds information on all the accounts that we have for our users. So if we want to store some different type of information within the same PowerCollection, so we're going to use our user-defined type for accounts now. As we did before, we're using the prefix command, but this time with the accounts user-defined type to add information to each of the elements. So we're using the account prefix and 1300. So this new user, Fred Smith, is going to have 2 records within the PowerCollection, a customer's record and an account record. And just as we did before, we're going to use the customer's add command to add this data to our collection. And just to be sure that this particular record has been added successfully, we can test the value of object result to see if it has been successfully stored. And if it has been successfully stored, we're pushing 2 messages out to our log: the key and the word stored, and also a count of the number of records we have in the collection, which should have gone up by another 1. So before we run that, I'm going to declare 2 additional user-defined types. One called customer out, which is again going to be based on the customer's type, and one called accounts, which is going to be based on the accounts user-defined type. We need the accounts one because we're going to be using it to put account data in for our new 1300 account. So if we try running that code now, we will see that the account 1300 has been successfully stored, and we're now up to 11 records within our PowerCollection. So as well as adding data to our PowerCollection, there will become a time when you wish to remove data from the PowerCollection. We wish to remove a customer's record. We have at the moment an account number 1200 for John Smith. So we're going to remove that record from the PowerCollection. We can do that quite easily by specifying the key, which is our user prefix and 1200. We can then use the remove method to remove that key and the data from the collection. We can again test to make sure that this has been removed. And we're putting 2 messages out to the log, one to say what we've removed and another to count how many records are now left. If we run our code now, we're now down to 10 records again. So account user 1200 has been successfully removed from the PowerCollection. So we have added and removed records. Can we update an existing record? We have an entry for account number 600. So we're going to make an update to that one to change its value. So first of all, we'll test to make sure the record exists in the PowerCollection. We will specify the key. We will then use the customers contains command to pull back the item number. If that returns 0, then no record has been found. If it returns a number other than 0, you can use that item number to pull back the actual data using the customer's entry command. This entry command populates the variable vData with the data that's within the collection. Alternatively, we can pull back the record into vData using a single line of code. As we have the unique identifier, the key, we can use that to pull the information back. And assuming object result is OK, we can then populate our user-defined type with the data from vData using the variant $command again. So the user-defined type customer out will be fully populated. So we said we wanted to update the data for this customer. So we can quite easily use the prefix command and update the data within this user-defined type. So we're changing in this case both the phone number and the address of this customer. So having updated the user-defined type, we can now replace the data in the customer's PowerCollection with our new data using the customer's replace command. As with the add command, it takes the same parameters. It takes the key and the name of the user-defined type containing the data we wish to push into the collection, replacing what was already there. And again, we can test our object result to ensure the account's been updated. So let's try running that code and see if it gives us the result we expect. And there is our message to say the data was found at record number 3, and the user 600 account has been updated. So what other commands can we actually use on our PowerCollection? Over time, the data being added to this collection would not necessarily be in any order, but there is a sort command you can use on the PowerCollection to sort it into the order of the key. We can perform this with a single command, using customers.sort. The sort command is followed in brackets with a number. If the value is 0, then the data items are sorted in ascending sequence. If you change this to 1, the items will be sorted in a descending sequence. So what if we want to move through each record in our collection and display it on screen? Again, we can do a for next loop for each vData in the customer's collection. The vData is of course the variant that's going to hold the data that comes out of each record. And we're picking up the record type as we did before, and we're going to test to see whether this is a user record or whether this is an account record, as they're using different user-defined types. So this will handle our user records. We're using the type set command to pull the information from our variant variable into our user-defined type. And we can then print out to our log the details of each element within the customers out user-defined type. And for the account records, we're doing something very similar. We're using typeset to pull the information into the accounts user-defined type, and we're pulling information from that user-defined type using the format command to turn the currency data back into strings which we can display on our log. And then a next command to get the next record. And before we finish off, we're going to save the collection back to disk, overwriting the customers.txt file. Remember, this now contains all the updated data and will allow us to actually see what we have. If we run the code now, you will see we have successfully saved the collection to disk. So we have updated the customers.txt file, and you will also see that the keys are now sorted in ascending order. So now that we have saved the collection to disk, you will see that account number 1200 is no longer in the PowerCollection. So when we run the application again, it will be unable to delete that record because it no longer exists. So let's try running the application once more to ensure we get that message. And there we are. Record 1300 is already stored. So we can no longer add it to the collection because it's already there. And record 1200 has not been removed because it doesn't exist within the collection. So in summary, what we've achieved today is we have created a PowerCollection to do an associative array. We've stored two different types of data within this collection: data on accounts and data on customers. And as we're using variants to pull the information back from this PowerCollection, we can determine what we need to do based on the prefix of our key. If it's user, we know it's user data, and if it's account, we know it's account data, and we can handle that data independently. So using this method, you can get quite flexible datasets stored within a PowerCollection. They can be then manipulated, added to, removed, updated, and even sorted. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.